Today we will be learning about the Pythagorean Theorem. Now you might have heard of this before from your middle school experiences, so we're just going to refresh it a little bit and talk about something called Pythagorean triples. So the Pythagorean Theorem lets us find a missing side of a right triangle if we know two other sides. If we have a right triangle and we have one side and two sides, we'll call those legs. And then C right here, the slanted line here is the hypotenuse. And if you do a squared plus b squared, that will equal c squared. So a couple of things to note is that the hypotenuse is always across from the box. The hypotenuse never touches that box. A lot of people make the mistake of always thinking that C is the value we're always trying to find. That's not the case. You always want to think about it as the hypotenuse, or C, is always the side that's not touching the box. And since we have addition here, it does not matter what side we label A or B, because addition, when you do that, the order does not matter. So we'll look at these examples here where we're trying to find out the missing side. First thing I always like to do is I want to figure out where my right angle is, the box, and then the side that doesn't touch that I label the hypotenuse, or hype. This tells me that this side should go by itself on the Pythagorean theorem problems. So Pythagorean theorem is a squared plus b squared equals c squared. And again, it doesn't matter which side you label A or B, you're going to get the same answer. So we have A is 24 plus B is 7 equals x, because we don't know what that is, so x squared. That's our Pythagorean theorem. So then we'll get our calculator out and we'll do 24 squared that's 576 plus 7 squared is 49, and that equals x squared. So 576 plus 49 is 625, and that equals x squared. We then need to take the square root of both sides, and when we do that, we get 25 equals x, and that is our answer. Over here, this is our right angle. This side that's 13 does not touch that right angle, so this is our hypotenuse. Now, the Pythagorean theorem only works in right triangles. So don't think that we can use this all the time. If we have any given triangle, there has to be this 90-degree angle there. So then I'm going to label the other sides A and B. And then I can set up my Pythagorean theorem. Now, we don't know what A is. See, over here, we labeled A with this side that's x. So instead of writing a squared, we're going to write x squared. Plus 12 is our b value. So 12 squared equals 13 squared. So this, again, this is where people make the most mistakes, is that they'll rewrite this in thinking that this is always our c, our c value in the theorem, that we're always trying to solve for that, but that's not the case. The number that goes by itself is always the hypotenuse, always, always, always. So then we'll solve this. We'll have x squared plus 12 squared is 144. And then 13 squared is 169. We'll then subtract 144 from both sides. Gives us 25. And then when we square root both sides, x equals 5. So this length up here in this triangle is 5. Right, on the next page, we have a story problem. The screen size of a TV is measured by the diagonal distance from one corner of a screen to another. A 55-inch TV is 30 inches tall. What's the smallest TV stand that you could put the TV on? So I'm going to just draw a picture of a TV. It says it's 55 inches, so this is a diagonal, or corner to corner, because that's what the problem says. So a 55-inch TV is that. And then it says it's 30 inches tall, so this is 30. And we want to know what's the smallest TV stand that you could put the TV on. So we're trying to figure out this distance here so that we know what size TV stand we have to buy. Well, I don't know about your TV, but my TVs always are perfect rectangles. So this is, whoops. So this is a right angle down here. So now we have this triangle right here, a right triangle. So I'm going to draw just that part separately, where the diagonal is 55. Okay, so this is our box, or our right angle. This side that's 55 inches does not touch, so this is a hypotenuse. So then it doesn't matter which side we label A or B. We're trying to find this side down here. So we'll set up a squared plus b squared equals c squared. So 30 squared plus b squared equals 55 squared. So 30 squared is 900. And then 55 squared is 3,025. Subtract 900 from both sides. B squared is 2,125. So then we'll take the square root of both sides. And B is equal to 46 point, we'll call it 1 inches, because that's what our units are. So the smallest TV stand we could put this TV on would be 46.1 inches. So we got to buy something at least that large. Now we're going to look at something called a Pythagorean triple. Pythagorean triples are sets of numbers that work well in the Pythagorean theorem so that we don't have a decimal like we did here with this example 2 in the TV. Up here, we can see some examples of Pythagorean triples because our answers were nice whole numbers. We didn't have any decimals. So Pythagorean triple satisfies a squared plus b squared equals c squared. And this chart tells us our most common ones and multiples of them. So like you see, we have 3, 4, 5. So if I multiply 3 by 2, I get 6. 4 times 2 is 8. 5 times 2 is 10. These numbers will work in the Pythagorean theorem, and the largest number in these triples is always the hypotenuse. So down here it says use a Pythagorean triple to find the unknown side length of the right triangle? Well, we have 30, 40. So if we look at our table up here, 30, 40, that means the missing side of the hypotenuse must be 50. So x equals 50. Then over here, we have x, 48, and 50. So if we look up here, okay, we have 48 and 50, so the missing one is 14. So this was our hypotenuse. So 14, x equals 14. Now, if you don't remember these Pythagorean triples, you can set up the Pythagorean theorem and you'll still get the same answer. The triples just allow us to save a little bit of time. So if you remember them, you can use them. If not, you can still use the Pythagorean theorem and things will be great. So I hope that this video is a good refresher. Make sure you like and subscribe.